Time travel has been a staple of science fiction for decades. Think of characters like Doctor Who, The Terminator, and the iconic Back to the Future trilogy. But while time travel might seem like pure fantasy, it's actually something that has intrigued physicists, philosophers, and scientists alike. The real question is time travel possible? Could we actually travel through time the way we do through space? Let's take a 5-minute journey to explore the science, paradoxes, and philosophical implications of time travel. The science behind time travel. Einstein's relativity. At the heart of any serious conversation about time travel is Albert Einstein's theory of relativity. This theory, which revolutionized our understanding of physics in the early 20th century, shows that time is not a constant, unchanging thing. It's actually relative, and it's intimately connected to space. Together, time and space form what is called the space-time continuum. Einstein proposed two types of relativity: special relativity and general relativity. Both have significant implications for time travel. Special relativity and time dilation. Let's start with special relativity, which is perhaps the most mind-boggling aspect. One of its key ideas is time dilation, which means that time passes at different rates depending on how fast you're moving. For example, if you were to travel near the speed of light, let's say in a spaceship, you'd experience time much more slowly than someone standing still on Earth. This is not a trick of perception, it's a physical reality. Imagine you're on a spaceship traveling at 90% the speed of light. You could travel to a distant star and back, and for you, only a few years might pass. But on Earth, decades could have gone by. When you return to Earth, you would have traveled forward in time relative to the people who stayed behind. In a way, you've experienced a form of time travel, but only forward. This is what's called time dilation, and it's been confirmed in experiments with atomic clocks flown on planes and satellites. The faster you move, the slower time seems to pass. So, theoretically, if we could somehow travel fast enough, close to the speed of light, time travel to the future is not just possible, but scientifically proven. General relativity and wormholes. Now, let's dive into general relativity, which deals with how gravity affects time. According to this theory, massive objects like stars and black holes warp the fabric of spacetime. The stronger the gravitational field, the slower time moves. This has led scientists to hypothesize that we might be able to travel through time if we could find certain phenomena in the universe, like wormholes. A wormhole is essentially a tunnel through spacetime that connects two distant points in the universe. If we could somehow find or create a wormhole, it might allow us to jump from one point in time to another, essentially bending time and space. However, creating or stabilizing a wormhole is an entirely different challenge, requiring enormous amounts of energy and exotic materials, like negative energy, that we don't yet know how to harness. But it's still an area of active scientific exploration. Time travel paradoxes. The grandfather paradox. Time travel to the past is a much trickier concept, and this is where we start to run into some mind-bending paradoxes. Perhaps the most famous of these is the grandfather paradox. Imagine you travel back in time and accidentally prevent your grandfather from meeting your grandmother. If that happens, your parents would never be born, and you wouldn't be born either. But if you weren't born, how could you have traveled back in time to prevent the meeting in the first place? This creates a logical loop, where cause and effect seem to contradict themselves. This is one of the major reasons why many scientists believe that time travel to the past might be impossible, because it creates paradoxes that challenge the very foundation of logic and causality. Other paradoxes exist as well, such as the bootstrap paradox. This occurs when an object or piece of information is sent back in time and becomes the cause of its own existence. For example, if you went back in time and handed Shakespeare a copy of one of his plays, which he then published as his own work, the play exists because you gave it to him. But where did the play originate from in the first place? It creates an infinite loop of information with no clear origin. Philosophical implications. The nature of time beyond the scientific challenges. Time travel also raises deep philosophical questions. If we could travel in time, what would that mean for our understanding of reality, choice, and free will? For instance, if you could travel back and change the past, Would you be altering the future in ways we can't predict? Some philosophers argue that even if time travel were possible, we might be unable to change the past, due to what's known as the Novikov self-consistency principle. This principle suggests that events that have already occurred must remain consistent with the timeline, meaning you would be unable to prevent your grandfather from meeting your grandmother because any attempt to change history would be part of the timeline that led to the present. On the flip side, if time travel did allow us to change past events, it could lead to a chaotic, unpredictable future. One where even the smallest action in the past could create vastly different timelines. Some scientists speculate this could lead to multiple timelines or parallel universes, where different versions of reality exist based on different decisions or actions. Is time travel possible? To sum it up, time travel to the future is not just a theoretical idea. It's actually been demonstrated in a limited way by science. Thanks to time dilation and the effects of relativity, we know that traveling forward in time is possible if we move close enough to the speed of light or spend time in extreme gravitational fields. However, time travel to the past remains highly speculative and presents serious logical and physical challenges, especially with paradoxes like the grandfather paradox. As of now, there's no known way to travel back in time without running into these paradoxical situations. Creating a wormhole, while an intriguing possibility, is still far beyond our technological capabilities. Philosophically, time travel forces us to confront deep questions about causality, free will, and the nature of time itself. If time travel ever becomes a reality, it could change not just the way we understand physics, but the very fabric of our existence. So, is time travel possible? In some sense, yes, we can travel forward in time with the right conditions, but traveling back in time, well, that might be something for science fiction, at least for now. If you enjoyed this deep dive into the mind-bending possibilities of time travel, don't forget to hit that like button and subscribe to the channel for more thought-provoking explorations of science, philosophy, and the mysteries of the universe. Got your own theories about time travel or questions you want answered? Drop them in the comments below. I'd love to hear your thoughts. And hey, if you're ready to explore more of the impossible made possible, check out our other videos on space, quantum physics, and the mind-boggling laws of the universe. Until next time, keep thinking beyond time.